Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss the question bank in graph theory. So, very first one is that explain in detail about graphs. So, graph is nothing but a generalization of simple concept of dots, links, edges, and arcs. And here, the graph should be represented as a set of vertices and edges. So, where the vertex set is going to be represented as V of G, and edge set is going to be represented as E of G. So, here, the vertex set and edge set is the combination what we're going to be considered it as a graph, and the set of vertices is going to be represented as V, and set of edges or can also be represented as E. So graph is defined by the ordered pair of set of vertices and edges, and that should be represented as G is equal to V comma E. So where V is the set of edges vertices and E is the set of edges connecting the vertices. Suppose if I am going to consider a graph here, so here the vertex set should be A, B, C, D, E, and edge set should be A, B, B, D, C, D, and AC, and D. And here the vertex, what is the vertex here? So vertex is nothing but individual data elements of the graph is called as a vertex, and this is also called as a node. And edge is nothing but a connecting link between the two vertices, and edge is going to represent it as arc, and edge is represented as starting vertex and ending vertex. So the next origin is that, so if the edge is directed and its first endpoint is said to be origin of it. And destination means if the edge is directed, then its first endpoint is said to be origin of it, and other should be destination of the edge. So these are the basic terminology of the graph, like vertex, edge, origin, and then destination. So what is the path here? So the path can be defined as a sequence of nodes that are going to be allowed to reach some terminal node, and the closed path is nothing but the path which is going to be called as a closed path if the initial node is same as the terminal node, and path will be closed if v not equal to vn. And next one is that adjacent nodes. So if the two nodes are going to be connected in an edge, then the nodes u and v are called as neighbors and adjacent nodes. And degree of the node is nothing but the sum of the is the number of edges that are connected with that node, and the node with the degree 0 is called isolated node. Okay, so the path can be defined as the sequence of nodes that are going to be allowed to reach some terminal node, and the path will be closed if the initial node is same as the terminal node. An adjacent node means if the two nodes are going to be adjacent, if there exists an edge between the two nodes, and degree of the node is nothing but the number of edges that are connected with that node. And what is that in degree here? So in degree is nothing but the total number of incoming edges connected to the vertex is nothing but in degree, and total number of outgoing edges that are connected to the vertex is said to be out degree. What should be the parallel and edges and multiple edges? So if there are two undirected edges with the same and vertices and two directed edges with the same origin destination, so such edges are going to be called as parallel edges and multiple edges. Self loop is nothing but, so the edge is the self loop if its endpoint is going to be coincide with each other. Then what are the applications of the graph theory? So here it is going to be used in electrical engineering, computer networks, and other applications. So in electrical engineering, the concept of graph theory is going to be used extensively in designing the circuit connections, whereas the types and organizations are going to be named it as topologies, and some of the topologies should be star topology, brick topology, series, and then parallel topologies. And computer networks means the relation between these two interconnected computers in the network are going to be follow the principles of this graph theory. And other applications is nothing but where you can able to use the route the cities between is going to be presented in the graph, and the hierarchical order information such as family tree are going to be presented as a special keys. And different types of graphs here. So we're going to have different types of graphs, what we can able to call as null graph, trivial graph, non-directed graph, directed graph, and connected and disconnected graph. And these and all will be under set what we call as regular graph, complete graph, and cycle graph, and then cyclic, and then acyclic graph. And under set will be what we call it as finite, infinite, bipartite, planar, simple, multigraph, pseudograph, Miller, and Hamiltonian graph. These and all will be different types of the graphs here. So what is the null graph here? So a graph whose edge set is empty is called as a null graph. In other words, a null graph does not contain any edges in it. That means this is the graph where it does not contain any kind of edges between that. And the graph consists of the vertices and there are no edges in it. That should be null graph. And trivial graph means a graph having only one vertex is called as a trivial graph, and it is the smallest possible graph here. And this graph consists of only one vertex and there is no edges in it since only one vertex is going to be present, and therefore it should be called as a trivial graph. And non-directed graph, so a graph in which all edges are going to be undirected is called as non-directed graph. And otherwise, the edges of undirected graph does not contain any direction. So if the graph is not going to maintain any kind of directions, then I can able to say the null should be the undirected graph. So the graph consists of four vertices, four undirected edges, and these edges are going to be undirected, so it should be undirected graph. Undirected graph means a graph in which all edges are going to be directed is nothing but directed graph. In other words, so all the edges of directed graph contain some direction, and this directed graph is also called as a digraph. So the graph consists of four vertices and four directed edges, and since all edges are going to be directed, it should be called as a directed graph. And weighted graph, so weighted graph is one where each edge is going to have the cost of traveling between the nodes here. So if I'm going, the weights is going to be assigned to each edge, then I can able to say this should be the weighted graph. Unconnected graph means a graph in which we are going to be visit from one vertex to another vertex is called as a connected graph. And in a connected graph, at least one path is going to exist between every pair of vertices. So that's why I can able to call this as the connected graph. So this is one graph and this another graph. Suppose if I'm going to join these two graphs with a straight line, I can able to call this as the connected graph. So in this graph, you can able to visit from one vertex to other vertex, and therefore one at least path between every pair of vertices. Therefore, it should be a connected graph. And disconnected graph means so this is one graph and this another graph. There is no connection between these two graphs. That's why it should be called as a disconnected graph. So a graph in which does not exist any path between the any pair of vertices is called as a disconnected graph. So the graph consists of two independent components which are disconnected, and it is not possible to visit the vertices of one component to the vertices of other component. So a graph in which there exists does not contain any path between at least one pair of vertices is called as a disconnected graph. And here this graph consists of two independent components which are disconnected, and it is not possible to visit from the vertices of one component to the vertices of other component. So this should be called as a disconnected graph. And regular graph, so a graph in which the degree of all vertices is same is called as a regular graph. So if all the vertices in the graph is of degree k, then it is called as a k regular graph. Suppose if all the vertices have degree 2, and therefore it should be called as 2. Therefore it should be called as a 2-degree graph. Suppose in a graph, so the number of vertices, number of edges that are connected in the graph is 2 here. So I can able to call this should be called as a 2 regular graph. And next one, so what is a complete graph? So a graph in which exactly one edge is going to present between every pair of vertices is called as a complete graph. So a complete graph of n vertices contain exactly n C2 edges. So a complete graph of n vertices is going to have exactly n C2 edges, and the complete graph of n vertices is going to be represented as Kn. So here each vertex is going to be connected with all the remaining vertices through exactly one edge, therefore it should be called as a complete. And what is cyclic graph? Cyclic graph or cyclic graph. So a simple graph of n vertices and n edges forming a cycle of length n, so is called as a cyclic graph. And in a cyclic graph, all the vertices are of degree 2. So here each vertex is having degree 2, therefore these are now called as a cyclic graphs. So see here, so this is one cycle, and this is also another cycle, and this is also another cycle. So in this graph, so I'm not going to obtain any kind of cycles, that's why it should be called as a acyclic graph. So a graph containing which at least one cycle is called as a cyclic graph. So in this graph, it is going to have two cycles. So that's why it should be called as a cyclic graph. A graph with two cycles in it, therefore it should be called as a cyclic graph. Then acyclic graph means that so a graph does not contain any cycle, then I can able to say that should be acyclic graph. So in this one, I'm not having any cycle here, and here also I'm not having any cycle. So that's why it should be called as a acyclic graph. So this is here the graph does not contain any cycle in it, therefore it should be acyclic graph. And next one is bipartite graph. So bipartite graph is the graph where the vertices are going to be divided into two sets x and y, and the vertices of x only join the vertices of set y. So they should be called as a bipartite graph. So examples of this bipartite graph is that, so we are going to have a set of vertices. So in this vertices we are going to consider one set of vertices is one side and another set of vertices is going to other side. So then the mapping is done in between this vertices pay. Then among this vertices there is no edge is going to be present. So that kind of graph what we call it as a bipartite graph. Okay, so the bipartite graph in the graph is a graph in which where the vertices are going to be divided into two sets, and the vertices of set x only join with the vertices of set y. Next one is planar graph. So planar graph is the graph where you can able to draw in a plane such that no two edges of it is going to be cross each other. And here the graph can be drawn in a plane without crossing any edges, therefore it should be a planar graph. So a planar graph means is a graph where you can able to draw in a plane such that no two edges is going to be cross each other. So if I'm going to two edges are going to be cross each other, then it should be called as a not a planar graph. The next one is pseudograph. Pseudograph means a graph where having no parallel edges but having self loops in it is what we call as a pseudograph here. So the example of pseudograph means, so here the graph is going to have three or more vertices and four edges, out of which one edges is a self loop and no parallel edges is going to be present, therefore it should be a pseudograph. A graph which does not have parallel edges, that means like this, and having the self loops, then I can able to solve this graph as a pseudograph. A graph having no self loops and no parallel edges is going to be called as a simple graph. Okay, a graph not going to maintain any parallel loops and parallel self loops and parallel edges. We can able to call this as the simple graph. So here the graph is going to have three vertices and three edges, and there are no self loops or no parallel edges, so therefore it should be a single graph. And next one is that what is a multi-graph here? So a graph having no self loop but having parallel edges in it, what we call as a multi-graph. A graph which is going to have multiple edges or parallel edges, then I can able to say they should be called as a multi-graph. And next one is Euler graph. So Euler graph is a connected graph in which all the vertices are going to have an even degree. So example, if I'm going to have a graph like this, so in which all the vertices are going to be connected at the same time, the degree of all the vertices is also even. So the degree of vertices 2 here also 2. The number of edges that are connected to the vertex is nothing but the degree here. So here there are two edges that are connected, that's why it should be 2. So here also 2, 2 and 2. So the degree of all vertices is going to have even degree, that's why it should be called as a even graph. And what is the next one is Hamiltonian graph. So if there exists a closed block in the connected graph, then every vertex of the graph is having exactly once without repeating the edges, then such graph is going to be called as a Hamiltonian graph. So if there exists a closed path in the graph and visiting all the edges exactly once without repeating, such graph is going to be called as a Hamiltonian graph. So this graph is going to have a closed path, closed walk here, which is going to visit all the vertices except the starting vertex exactly one, and all the vertices are visited without repeating edges. Therefore, it should be called as a Hamiltonian. And these are the differences what I observed between the simple, multiple, and pseudo graph. So if you are going to consider a simple graph, so the simple graph may not have self loops and no parallel edges. And multi-graph means no self loops but parallel edges is going to be present. And pseudo graph means which is going to have self loops but does not have parallel edges. And another question is that discuss different types of graph presentations. So here I'm going to have different types of graph representations like adjacency matrix, adjacency list, and then incident matrix. So these are the different ways of representing a directed graph. So first one is the adjacency matrix, list, and then incident matrix. So what is the adjacency matrix here? So in this representation, the adjacency matrix of the graph should be two-dimensional. So that too, this matrix is going to be filled with values with ones and zeros. If there is an edge from Vi to Vj, otherwise it should be 0. So the matrix is going to be symmetric in case of undirected graph, while it may be asymmetric if the graph is going to be directed. So the adjacency matrix is going to be represented for undirected graph and directed graph. So if I'm going to have a graph like this, and how can I able to represent the adjacency matrix here? So for this, first we have to represent the set of vertices among the rows and columns. So whenever there is exists an edge from one vertex to another vertex, I can able to represent it as 1. So if I'm going to represent I have edge from AB, so that's why I'm going to represent 1. So I have an edge from A to D, so that should be 1, right? So next one, so if I'm going to consider B here, so B to A, B to C, B to D, and is there. So that's why I'm going to represent B to A, C, and D should be 1, so remaining all should be 0. So if I'm going to consider C here, so I have edge from C to E and C to B, so C to B and C to E is going to be present. So like this, we are going to be filling the values in adjacency matrix. So while it comes to the directed graph here, so here there exists a different matrices for which the directed and undirected graph. So in directed graph, the entry AI will be 1 only if whenever there exists an edge directed from Vi to Vj. So directed graph and its adjacency matrix representation is shown in the figure. Suppose I'm going to have the directed edge, so similarly I'm going to consider the set of rows and set of columns here, And if I'm going to draw an edge from A to B, so that should be 1. So only one edge is going to be directed, so remaining all should be 0. Suppose if I'm going to consider E here, so for E I'm going to have only one directed edge, E to D, that's why it should be 1. And suppose if I'm going to consider B, so B is going to have B to D and B to C, so that's why I'm going to present it as 1. And weighted graph means, so I have to represent the weights in the matrix instead of edges. So if I'm going to have the edge from A to B, I have an A2, and B to C I have H2, and E to D I'm going to have the weight 10. So like this I'm going to present it. So representation of weighted directed matrix graphs is going to be different one. So instead of filling 1, so here the non-zero entries of adjacent is going to be presented by the weights of these respective edges. And the weighted directed graph is going to be shown like this. And next one is incident matrix. So incident matrix means, so in this representation, so the graph is going to be represented by use of a matrix of size that should be equal to the total number of vertices by the total number of edges here. And that means if the graph is going to have 4 vertices and 6 edges, and the matrix size will be 4 by 6. Okay, so let me show that. Okay, so in this matrix, the rows are representing the vertices, and where the columns are going to represent the edges here. And this matrix is going to be filled with 0, 1, and then -1. So 0 means there is no row edge is not connected, and to column vertex. And 1 means, so they represents a row edge connected between the outside edge. And -1 means the row edge is connected as incoming edge to the column vertex. So if I'm going to consider this instant matrix, if I'm going to have a graph, so I'm going to consider the vertices as rows and edges as columns here. So whenever I'm going to have an edge, I'm going to be able to represent 1. So E1, E2 is there, and E3 is there, so that's why I'm going to represent -1 here. Similarly, if I'm going to consider, so E4, E6 is there for B, so E4 and E6, but I have one incoming edge, that's why it should be -1. Similarly, if I'm going to consider C, so for C I have only E5 and then one incoming edge, that's why it should be -1. So incident matrix in case of undirected graph is also same, so but it should be like -1s are not going to appear. So adjacency list. So in this representation, so the n number of rows of adjacency matrix are going to be presented as n list, linked list, an array of pointers where for 1 less than b less than n, the linked list containing the vertices which are going to be adjacent to b. So if the edges is going to have the weights, and these weights may also going to be stored in the form of linked list. So adjacency list in case of undirected graph. So adjacency list is going to be maintained for each node that is going to be present in the graph. It stores the node value and a pointer value to the next node to be presented. So if all the nodes are going to be traversed, then we're going to store the null in the pointer field of the last node of the list. And if the sum of the lengths of adjacency list should be equal to twice the number of edges that are going to be present in the undirected graph. So this is the graph. So how we are going to represent the form of the adjacency list here. So we are going to have a set of vertices, and the vertices that are going to be connected represent in the form of a linked list node. So here then this should be going to present the data, and this is going to store the address of the next field. Okay, so if I'm going to consider D, so the edges that are vertices that are connected to D is that D to A, B, and then E, so which is going to be connected by means of pointer or link field by make use of this adjacency list. Similarly, in case of directed, it should also same. So based on the directed edges, I'm going to represent the adjacency list. And adjacency list in case of the weighted graph means, so here I'm going to represent the adjacency nodes, but instead of link, I'm going to maintain one more field that should be for weight of that edge. So since I'm going to draw the weighted graph, so along with the vertices of the node that is going to be connected, so the weight is also going to be represented in this weighted graph in case of adjacency list. So one more field is going to be added. So one is your data and then weight and then length. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.